Terima kasih. Kemarin ada mahasiswa Fisika ini diberikan pemahaman tentang komunikasi, frekuensi tentang ilmu sabda pangrumu kemarin. Sekarang ada mahasiswa akan menerima pengetahuan yang sangat berharga tentang AI, AI wireless sensing. Profesor Akira UCHIYAMA, Hiroki UCHIYAMA. Oke. Dan ini sangat berharga sehingga lulusnya cepat 2 tahun kembali ke Palangkaraya. Jadi mohon disimak dengan baik ya. Ini sangat bermanfaat sekali. Dan Fisika merupakan salah satu program studi yang selalu menjadwalkan di luar jam kerja, bukan? Nanti dijelaskan sama Pak Dirga, kenapa tepuk tangan gitu ya? Karena Anda selalu menjadwalkan di atas jam 14, kami tutup ya. Silakan dinikmati. Barangkali itu saja, saya ada keperluan lagi, mohon izin untuk meninggalkan kompleks ini. Terima kasih. Arigatou gozaimasu. Assalamualaikum warahmatullahi wabarakatuh. Foto boleh.
Ladies and gentlemen, before we process, let's take a group photo. Hadirin dipersilakan untuk mengambil tempatnya masing-masing.
Ada mana? Ada di sana ya. Gimana cara supaya kelihatan di depan? Video sekali. Oke. 2 1 2 3. Salam Fisika. Grow together in the harmony of physics.
Terima kasih. Hadirin dipersilakan untuk duduk kembali. Now, let us continue the main agenda of today's program. This session will be moderated by the Vice Dean for Student Affairs, Bapak Made Dirgantara, MSc. With that, we kindly invite Bapak Made Dirgantara to lead the session. Kepada Bapak Dirga dipersilakan.
This is my session. Oke, baik, mungkin nggak terlalu panjang karena waktu sudah ini. Pertama kami mengucapkan terima kasih kehadirannya dari Bormun. Ini berjalan langsung gitu. Setelah kemarin kita berdiskusi terkait dengan frekuensi aturannya, nah itu saya bilang nanti ada yang perlu dilihat gitu. Ada yang perlu dilihat karena kita juga menggunakan beberapa kegiatan terkait sensing menggunakan radio frekuensi. Untuk ada mahasiswa di sini dari TI ada? Nggak ada? Dari TI? Ini padahal di depan orang TI semua. Kemarin saya undang 5 orang paling enggak hadir di sini dari teknik informatika. Berarti selebihnya adalah matematika, biologi, fisika. Ada yang dari luar itu? pendidikan fisika juga. Oke. Nanti tamu atau pembicara kita akan menyampaikan presentasinya dalam bahasa Inggris. Jadi harapannya kalian coba simak semaksimalnya. Potensinya adalah untuk yang mahasiswa mau tingkat akhir. Jadi kami ada riset bersama gitu. Mereka ada beli alat dan alatnya ditinggalkan di kita gitu. Bagusnya begitu, alatnya ditinggalkan di kita, jadi bisa kita gunakan untuk riset. Jadi riset-riset kecil yang nanti bisa berkolaborasi, yang kita pembimbingnya nanti beliau-beliau ini menjadi salah satu pembimbing eksternalnya. Artinya itu akan selangkah lebih awal untuk yang ingin kuliah misalkan di Osaka gitu. Selangkah lebih awal yang ingin kuliah di Osaka. Dan juga mungkin kalian akan mendapat pola pikir yang berbeda dibandingkan dengan pola pikir yang selama ini dosen-dosen kita ajarkan gitu. Jadi harapan saya disimak semaksimal mungkin gitu. Jika ada hal-hal yang tidak dimengerti ataupun hal yang menarik gitu, sesuatu yang menarik, Pak saya tertarik dengan kata ini, nggak apa-apa sampaikan gitu. Terkait dengan kata ini kita bisa minta mungkin penjelasan lebih lanjut atau bahkan makna dan artinya apa gitu, itu juga bisa. Karena waktu mungkin juga cukup mepet tadi ya, cukup mepet. Nanti mungkin saya akan persilakan dulu beliau-beliaunya presentasi. Pokoknya diusahakan disimak seininya. Saya tidak menerjemahkan ya. Biasanya kan saya terjemahkan gitu. Nanti saya akan kasih intisarinya di bagian belakang gitu. Intisarinya di bagian belakang. Apa sih yang yang dipresentasikan? Apa sih yang sedang dikerjakan gitu. Tapi bagi yang berusaha mengerti itu, saya harapkan keaktifannya untuk berani menanyakan sesuatu sesederhana apapun itu boleh ditanyakan. Tidak berlama lagi. Uchiha, say you in person for the first time. Saya mungkin memperkenalkan Profesor UCHIYAMA Akira UCHIYAMA. Profesor Akira UCHIYAMA. Dia adalah dosen di TI, Teknik Informatika, Fakultas Sains Osaka gitu. Sains in Technology, right? Di fakultas. Information Science and Technology. Jadi kurang informasinya di depan gitu. Information Science and Technology. Jadi dia salah satu profesor di sana. Kemudian di sebelahnya Dr. Hiroki KUDO. Hiroki KUDO. Itu dari Kyoto Tachibana University di Kyoto, tapi beliau juga ada kegiatan di Osaka University. Jadi beliau berdua datang ke sini tanpa dibayar, tanpa dibiayai, tanpa dikasih apapun. Transport malah mereka yang ngasih kita gitu, ngasih alat bahasanya itu kita sangat berterima kasih sekali. Okay, Sensei, please introduce yourself and then continue for the presentation.
How long?
Maybe 30 minutes.
20 minutes? I will start.
Maybe 30 minutes maximum.
Yeah, okay. I have. So please stop. Okay, so thank you very much for your kind introduction. So good afternoon, everybody. So I'm Akira from the University of Osaka. So actually, our university has changed the name. Have you noticed? Yeah. Previously, it was Osaka University. But now, the University of Osaka. Yeah, there are some complicated story behind. So if you have interest, please check. And I learned some words. I mean, Indonesian from Dilga. And what I remember is tidak tugas. sit up class. This is super important to survive.
Mereka nggak makan pedas. Nggak bisa makan jagung.
Okay. So yeah, so I'll be talking about wire sensing. Yeah. So, but I will also briefly talk about some research that I have done maybe when I was young. Young means maybe assistant professor. So yeah, this is my brief biography, and yeah. So actually, I started my undergraduate study at University of Osaka. So since then, yeah, I have been in Osaka, yeah, for more than 20 years. Yeah. So yeah, now I'm Osakan people. But meanwhile, after I received a PhD degree, I had a chance to visit the United States for 1 year, and then I returned to the University of Osaka and I joined the faculty. Yep. And this is just a short introduction, some information about the University of Osaka. This is all. So yeah, it was founded in 1931. So it's around 90 years. And it's one of the national universities in Japan. And there are 7 former imperial universities in Japan. So one of the biggest universities in Japan. And we have 3 campuses in Osaka Prefecture. And currently the World Expo is held. And I visited the Indonesian pavilion. And the KUDO Center, I have visited. And we enjoyed a lot. And we found some anyway, yeah. And so as I said, it's the Japan third largest university. No, not university. Osaka Prefecture is second in population.
No, sorry.
Third.
Sorry.
Yeah. Okay. And this is about the collaboration ranking. Sorry, in Japanese. The top is the University of Tokyo. The second is the University of Osaka. So that means we have a lot of collaboration with the companies. Maybe because in Osaka there are many small companies. And for undergraduate, so of course we have graduate schools, but for undergraduate schools, we have a lot, like schools of data, human sciences, for instance, in law, economics, and also some engineering science. And I am a faculty member of engineering science in terms of the undergraduate teaching. And regarding the graduate school, I belong to the Graduate School of Information Science and Technology. And it was founded in 2002. But anyway, 5 minutes passed. So, why we are here? Because we have research project with Asumi Sensei and some other Oda Sensei from our university as well. And yeah, so we are doing some experiments about surround markets. And the motivation of this research is actually Oda Sensei asked me about this problem, and we had some discussion, and we decided to start with this project. So the point is the balance between animal welfare and ecology, right? Because people build buildings for birds, and they harvest the nest and sell it, right? But what happens if there are eggs in the nest when the time of the harvest? So in that sense, we need to make balance between the animal welfare and ecology. So the best way is to harvest the nest soon after the completion of the nest building. But it's basically not so easy to identify such time. Yeah, because maybe we can put some camera, but it's the camera lens can be easily contaminated. It can become easily dark because it's in the sunlight building, right? So how can we monitor the nesting? That is our key question. So we have so far we have collected some data. We started with millimeter wave radar, and as you can see in this picture, we put millimeter wave radar here, and we try to monitor ideally, we want to monitor behavior, birds' behavior about the nest building. But first we have started with counting the number of birds in the area by using a millimeter wave radar. And I avoid the technical detail. But basically, we combine the millimeter wave radar data with deep learning, and currently we successfully classify the number of birds in the range with a high accuracy. But of course, this is just a starting point, and this time, actually from this morning, we have started to collect another data, which is RFID. So we attach RFID tags on near the nest, and by observing the change of the phase information from each tag, we want to estimate the birds activity. So hopefully, we can report the progress next time. So this is about what we are doing here in Paraka. And so back to my research, 10 minutes. Oh, 10 minutes remaining.
No.
I need to speak. Okay. Anyway, so back to my research. Recently I'm mainly working on the wireless sensing, but I have been working on some IoT sensing, so Internet of Things. So, for example, by using smartphones, we estimate the locations of people. By observing exchange signal among users. Or sometimes, yeah, I use smartwatch, like accelerometer or gyro sensor to monitor the daily, to recognize daily activities. So it's not about the wireless, but the data is delivered by wireless, of course. And yeah, so depending on the target context, like user locations or urban context, which means some crowdedness, for example, in urban areas or railway stations. Yeah, or yeah, I also have some work regarding healthcare, but I think KUDO sensei will talk more about this part. So yeah, depending on the targets, I design the best combination of the sensors and how to process those. So that is, yeah, roughly speaking, my research. So I will quickly introduce my research. So this is about train congestion estimation. So by observing the Bluetooth signal strengths among users on train, we can estimate the congestion level in each train car. I am not sure if you have experience. Yeah, yeah, using trains. Okay, yeah. So in Japan, maybe you can check some YouTube videos, but yeah, especially in Tokyo, the rush hour is still. And even it's not rush hour. Yeah, some trains are very crowded. So we want to provide some information to the train passengers for more comfortable travel. So the point, the key idea is if you observe the signal strength from the other smartphone, if there are some people in between, then the signal strength will decrease, right? So yeah, that's the storage point, right? But the point, the challenge here is we don't know the exact location of each user. So if we need to distinguish if this weakness of the signal strength is due to, not due to distance, but due to the human factor. So, so the point is that we collect a lot of data beforehand, and we build some model to estimate the congestion. And I have also another work regarding the context recognition and congestion estimation in train stations. So here context means the location of escalators or elevators or ticket vending machine or gates or something like that. And simultaneously we estimate the congestion level, so the length of the queue or yeah, something. So here we combine multiple sensors embedded in the smartphone, and we collect data from multiple users in the station. So this is the application, and I have some others, but I will skip. This is like using camera for prevention of COVID-19. So, yeah, so we did this kind of thing as well. And this is about healthcare, like estimating body part temperature using a wearable sensor. But yeah, so I will also talk about the wireless sensor because it's in the title. So Yeah, I have a lot of work about IoT, but actually yeah, I experienced a lot of difficulties like this. So for IoT sensing, we need a lot of sensors, and it's super hard for preparation, right? And even after deployment, maintenance is super hard because there are many sensors, right? So that's why I started wireless sensing. So wireless sensing is the concept is a bit right, but yeah, one of the well-known approaches is Wi-Fi. So, for example, by observing the change of the Wi-Fi signal, we can estimate the user behavior. Like, for example, in elderly monitoring, we can detect fall. So fall detection is possible by observing Wi-Fi signal. And also some activities like walking, running, or sitting. Yeah. So such kind of activities can be recognized by observing Wi-Fi signal. And the good point is wireless sensing is yeah, it's widely deployed basically if we focus on Wi-Fi. So the cost is low in terms of deployment. And we don't have to worry about the energy because basically we don't have to attach any device on board, right? So we don't have to charge, right? And Wi-Fi devices basically plugged to the power socket. And general approach for wireless sensing is we collect data and train some machine learning model. That's a very typical approach. And so why can we recognize activities by observing wireless signals? So, well, intuitive example is even in this room, if you are here, you observe some signal strengths from some Wi-Fi access points, right? And if you move to another location, you will observe different signal strengths at that point. Right? So that is because the signal propagation changes due to the environment difference. And so based on physics, yeah, yeah. So Wi-Fi signal propagates with attenuation, reflection, diffraction due to some obstacles like walls or furniture, right? And human body is also obstacle. Right? So if so we are moving obstacles. Right? So if we move, the signal propagation changes. So by observing that signal propagation change, we can recognize the human factor. Yes. 20 minutes. Okay. 5 minutes.
You have a chance.
Really?
Yeah.
I will try. Thank you. So, so how can we obtain useful information for wireless sensing in Wi-Fi? So, actually, if I remember correctly, the new IEEE standard has been released this April or March, and it's about Wi-Fi sensing. So in near future, maybe next year, 2 years later, some products, Wi-Fi devices or Wi-Fi access points may be in the market. Yeah. And currently, for research purpose, we can use several Wi-Fi modules to capture information which can be used for Wi-Fi sensing. And that is called channel state information. And this is also called CSI function. And this CSI can tell much more than the signal strings. That can tell the phase as well. And for each subcategory, we can. We connect to the one of the Wi-Fi channels. So there are around 10 or 13 Wi-Fi channels. But in each channel, the frequency is separated to multiple subcategories, actually. So in CSI, we can obtain the amplitude and phase information in each subcategory. So it provides super rich information. And by observing the phase change or amplitude change over time, we can recognize many types of activities. And there are so many things. So I will just show you an intuitive example. It's about people count. So this shows the amplitude change over time. So x is time and y is amplitude. So if there's nobody, the amplitude is stable. And if there are 3 persons, it fluctuates over time. 6, 9, so the fluctuates becomes large with the increase of the number of people. So this is just intuitive. So that kind of signal fluctuation can be used as features for the input of the machine learning model. So we can train some, for example, regression model, and we can estimate the number of people in the area, something like this. I will skip. But actually, there are so many papers about the Wi-Fi sensing, and but the biggest challenge here is actually the model training is very critical, because the models also run the environment-specific signal propagation. So that means if we change the environment, the training model doesn't work. So you have to correct the training data again. And data collection is the most the hardest process in machine learning or deep learning, because we have to collect a lot of data, and it takes time, and you have to repeat a lot of activities. So it's not practical. So there are some work about how to solve such kind of problems, like using fine-tuning or like many AI techniques. But I don't have any slides about that. So I will. And another approach is backscatter sensing. So this is also about wire sensing. So backscatter is actually used in RFID. Have you heard of RFID? Maybe no? RFID. Do you know?
Radio frequency ID.
ID. Maybe IC card. It's similar to IC card. So if you have Apple Pay or Google Pay, I don't know. But your smartphone may also have this kind of functionality. So backscatter is communication using signal reflection. So it's, let me show you. This is can you see? Something is lighting here, right? Blinking, right? This is backscatter. So by change, in this case, the sunlight is the source of the backscatter, and the mirror is kind of tap. So by changing the angle of the mirror, you can change the state of the light reflection. So then you can send information about there's reflection or no reflection. So it's about 0 or 1. So binary data transmission. So we can do the same for the radio frequency. And that is backscatter. And the good thing of the backscatter is it's ultra low power. So generally speaking, the power consumption of the common wireless technology, Wi-Fi, Bluetooth, yeah, they are on the order of milliwatts, like 10 milliwatts, 100 milliwatts, something like that. But if we use backscatter, it's 1,000 times less energy consumption. So it's microwatt. And so how to generate flashes in radio frequencies? So how to change the angle of the mirror in terms of the radio frequency? So it's quite easy. We can just use the RF switch. It's a tiny transistor. And if we change the state of the switch, we can change the status of the reflection, signal reflection. And this makes the radio frequency backscatter. So this is it may be difficult to see, but the tag is attached at the door, and it's hard to see. This is a spectrum, so this is a frequency, and you see the source signal to be backscattered here. And we cannot see, but there's a peak here, and which is from backscatter. So here, when I open the door, the backscatter signal disappears, and when I close the door, the backscatter signal appears. So by observing the change of the RF signals, we can directly measure or recognize the state of the object, like the door is open or closed or something. Maybe I will skip that. We tried the various types of sensor, backscatter sensors, like pedometer, seating sensor, temperature sensor, and so on. Skip. And 30 minutes, so I should stop here. But I am also working on some integrated sensing and communication, which is about using cellular signals for sensing. So it's about, for example, tracking the motor cycles by using cellular signals. So it's like radar. But the good thing is as I said in the Wi-Fi sensing, we can use widely deployed infrastructure for another purpose, which is sensing. So not only communication, but also sensing. We can use the signals. some projects about that, and some other sensing applications we are working on, but I will stop. And I hope, I believe we will visit here many times. Because we have just started RFID sensing for some wireless, so I hope I have a next chance to report our progress. So thank you very much.
Thank you very much. Oke, ditampung dulu ya. Maybe we can continue for KUDO sensei. Kita lanjutkan ya ke selanjutnya. KUDO sensei ini salah satu yang bisa memanfaatkan AI dengan baik. Jadi mungkin silahkan dilihat. Jadi kalau untuk ininya sebenarnya dia gini. Mana itu? Hilang. Selama lagi kalau nyarinya. Jadi intinya dia bisa memanfaatkan AI untuk istilahnya pengamatan atau segala macam lah. Jadi nanti kita akan lihat lebih lanjut. Untuk UCHIYAMA sensei nanti akan saya jelaskan di akhir. Please KUDO sensei, the stage is yours.
Thank you for introduction. I'm Hiroki KUDO. I'm an assistant professor in Kyoto, Tachibana University, Japan. So today I will talk about this topic, AI, how AI works, our monitoring, our smart monitoring. The title is From Physiological Data to Smart Insight, how artificial intelligence transforms monitoring technologies. First of all, let me introduce about myself. My name is Hiroki KUDO. I'm an assistant professor on the Department of Information and Computer Science at Kyoto Tachibana University. This is my picture, and the right picture is the position of the Kyoto Tachibana University in Japan. It's near by the Osaka prefecture. And this is my simple brief biography of me. Actually, I was in the Osaka University during my PhD program, and after that, I worked in Kyoto Tachibana University as an assistant professor. And this is my research interest. My research interest is about healthcare or sports sensing using wearable sensor or smartphone or any other sensors like thermography. And my research is related on the machine learning or artificial intelligence. So today I will introduce about that. So let me begin with artificial intelligence. AI refers to software systems that enables computers to perform human-like functions such as memory or reasoning or judgmental learning. One of the core technology behind AI is machine learning. Machine learning focuses on modeling how computers can use human data to recognize and understand relationships between things. In short, AI provides the broader framework, while machine learning is one of the key methods that makes AI possible. Okay, first of all, I introduced machine learning and the problem of imbalanced dataset for. Sorry. Basically, machine learning is mainly used to estimate how to measure data from easily measurable data. So, for example, the measurable data is 3-axis accelerometer in the like smartwatches, and machine learning try to estimate how people act like work using this accelerometer data. And the physiological data sensing allows us to capture human conditions and represent aspects of daily life as data. So there are two main types of sensors in this slide. First of we have fixed sensors. Examples include thermal camera for body temperature, and even images and video. And the second is the light one. We have wearable sensors such as smart watches. These can measure signals like heart rate or sweat level of the skin and other time series data. By combining the different type of data, we can gain a deeper understanding of human conditions in our daily life. Here I will talk about physiological data sensing using wearable devices. First, let's look at wrist-worn device. These can measure a wide variety of signals like heart rate or electrocardiogram. It's like sweat level, or microphone or accelerometer or gyroscope and light level and body temperature and electrodermal potential on the skin. And the next one is ear attached devices. They are also capable of measuring key signals like heart rate or body temperature. And they are also developed as sensing devices such as ring or clothes or glasses. By combining data from these different wearable sensors, we can obtain a rich set of physiological information to support AI-based estimations. And now I will explain about how we can use physiological data to train AI. The first step is feature design. This can be done in different ways, like, for example, we can use statistical metrics such as mean or variance of such data, and we can also apply image processing techniques, making use of shape and color for tasks like detecting facial regions or such as whole face or nose, lips, or cheeks. And another example is extracting the palm regions from the photo of the images of hand. Once these features are designed and extracted, they are then used as input to the AI model, which runs to make an estimation based on them. So let me introduce about my concrete our work, thermal sensation estimation using physiological data. Yeah, the research background is something detailed, but I explain briefly. Now let's look at the background of this research, estimating thermal sensation through human body sensing. Traditionally, thermal comfort is often evaluated based on the surrounding environment, such as air temperature or humidity. However, it is difficult to accurately capture the individual thermal sensation using environmental sensing alone. To address this problem, we look at the individual thermal sensation using the physiological data. This is commonly measured using the Ashley 7-point scale in the light image, which represents thermal comfort from -3 to the +3, range from cold and hot. In fact, many studies on thermal sensation rely on this 7-point scale as a standard method of evaluation. So yeah, we use this scale to estimate thermal sensation. Here I want to highlight the key idea of this research. First, thermal sensation is not determined only by the current environment, air temperature, something like that. It is also influenced by past environment. This means that even under the same setting, people may feel differently depending on their prior conditions. We can also see this in how thermal sensation codes or TSV changes with room temperature in the graph of light figure. When the room temperature changes suddenly, we observe TSV does not shift immediately, but rather changes gradually over time. Because of this, time series modeling becomes very important. So by considering changes across time is important of the thermal sensation estimation. So let me now introduce a use scenario of this approach. We begin with physiological data. For example, using thermal camera, we can capture skin temperature through opportunistic sensing and light figure from a smartwatch. We can measure signals like heart rate or other time series data. Next, we also include environmental sensor data such as temperature or humidity. And by combining these different sources, we can perform thermal sensation estimation. And finally, this enables practical application. For example, cross recommendation in that room or the automatic air conditioning control. This is a detailed estimation flow, but I simply and briefly explain this, right? First, we collect environmental sensing data such as air temperature or humidity and combining the physiological signal data such as heart rate or skin temperature or electrothermal activities, which changes depends on the skin sweat level and the facial skin temperature from thermal camera. After that, we move on to the pre-processing. Here we generate a feature vector that includes the information of physiological and environmental data. And then this vector becomes the input to the deep learning model, which is one of the techniques of the machine learning. And finally, the model provides the output and estimate of thermal sensation. And this is a detailed method, but it's a little bit complicated. So yeah, I will skip this slide. Yeah, and then we conduct the actual experiment. We collected the data from 21 participants over the 123 days, and from them we got the 1,442 summer images and the summer sensation boards. And for data collection, we use the smart wristbands data, which can measure the heart rate or skin temperature and sweat level. And for the opportunistic sensing, we use the thermal camera. And the thermal sensation board is collected by the smartphone application. The subject inputs the thermal sensation board, the range from -3 to +3, cold to hot. And yeah, I conducted the two types of experiment. The experiment A is the subject stayed in the single room with a fixed air-conditioned environment, and the experiment B is under the dynamic air-conditioned settings. And the evaluation matrix is called League 1 group out cross validation, where the 21 participants were divided into 4 groups. And for estimation accuracy, the thermal sensation values reported in increments of convoluted into 3 classes from 1 to -1, 1, 0, 1, -1. A means warm and neutral and cool. In, from the time restriction, yeah, I will skip this detailed processing. Yeah, and this is the result of our method. We confirmed that our proposed method achieves the highest evaluation metric and the lowest error compared with the baselines. And the results also highlight that adding time series information improves estimation accuracy of the thermal sensation, and this improvement makes the method applicable to recommendations or related practical scenarios. And we also should note that adding more explanatory values requires additional devices, so which also increase the cost of the systems. Yeah, and this is the summary of this work. In this study, we proposed a thermal sensation estimation that combines both cross-sectional data and time series data as an input. In the performance evaluation, our method outperforms existing approaches in terms of both the accuracy and the absolute errors. And furthermore, we found that considering the past 10 minutes, time series data is most effective in evaluation under air conditioned environment. Okay. Yeah, and let me introduce about the generative models of AI briefly. Yeah, this topic is about the data balancing. this is also the main topics of the AI or massive learning. This is one of the pre-processing methods dealing with imbalanced data sets. This is because the subjects cannot stay long in such severe environment, like extremely cold or hot. So the physiological data sets are inevitably imbalanced. And then we use the data generation method using AI. A representative example is GANs. This is called Generative Adversarial Networks. This is firstly proposed in 2014. Since then, GANs have attached significant attention in the field of human image generations. And this is the key ideas of GANs. Here I will explain the basic idea of GANs. And we start with random noise in the left lower figure, which is fed into the generator to produce synthetic samples. And at the same time, we have a discriminator, which is given both the generated sample and the original real samples. Its job to decide whether the input is real or fake. The key point is that the generator can discriminator are trained in turn. The generator tries to fool the discriminator while the discriminator learns to detect fake data. Through this process, the generator gradually improves the produce increasingly realistic samples through this training. And we use this technique. The sequence is proposed and in the current research. In normal GAN, the generator creates samples starting from only random noise, and the discriminator simply judges whether the sample is original or not. There is no control over what kinds of samples is generated. In contrast, in this is CGAN, we add an extra piece of conditioning information, for example, a class level or some attributes. There is no control over and the generator produces samples that correspond to the conditions, while the discriminator checks not only real values, real versus fake, but also whether the sample is matches the given conditions. And this means that unlike standard GANs, which generate random noises, random outputs, conditional GANs allow us to guide the generation process. For example, we can generate images or digits corresponding to the specific number, or even produce faces with desired attributes such as smiling or wearing glasses. Okay, and we apply this figure to the generation of the sample sensation dataset. And this is the detailed method of our generative models. And we also correct the dataset and originally and from the open data. And this is key architecture, and this is evaluation metric. Yeah, this is the result of our method. We compare our method with 3 methods. And the result shows our method increase the diversity for the all of datasets compared to original models. Yeah, let me conclude. Yeah, this is the conclusion and summary of this talks. The artificial intelligence transforms monitoring technologies using smart sensing techniques of physiological data. And collecting large amounts of physiological data and extreme environment can be escalated difficult. So we use the generative model is the key idea to address this problem, and the generative models are expected to be useful for data augmentation and expand data sets. Yeah, that's all. Thank you.
Thank you. Oke, baik, saya akan menjelaskan intinya saja. Jadi, jadi yang pertama, ini berpikirnya misalkan yang disampaikan oleh UCHIYAMA Sensei tadi, WiFi biasanya kita buat apa sih? Buat koneksi gitu. Tapi ternyata WiFi itu bisa digunakan untuk mengamati suatu perilaku gitu. Mengamati suatu perilaku. Kenapa itu digunakan? Karena kalau kita misalkan pakai sensor yang ditempelkan ke tubuh manusia, ke pinggir, ke kiri, kanan, itu untuk instalmennya terlalu ribet gitu lah. Bukan ribet ya, terlalu banyak gitu. Terus maintenance-nya juga susah. Nah, tapi kalau kita pakai wireless gitu, itu kita untuk ya maintenance-nya kan mudah, jelas, energinya lebih rendah, nggak terlalu banyak. Jadi kita bisa memanfaatkan gelombang WiFi untuk mengamati suatu perilaku. Makanya kalau misalkan tadi saya undang biologi juga di sini, ya siapa tahu ingin mengamati perilaku mencit gitu kan, pakai gelombang tertentu gitu. Jadi nggak perlu, kalau bisa pakai kamera, oke, batasnya tertentu. Terus datanya jadinya bukan datanya yang sangat besar ya, ukurannya yang sangat besar gitu. Tapi kalau kita ambil adalah bentuk teks, data yang bisa kita kompilasi ke dalam suatu tertentu gitu. Jadi kalau misalkan WiFi-nya di sana, kita mendekat, berarti signal strength misalkan pakai HP gitu ya, kita akan lebih kuat, terus menjauh. Jadi kita bisa melihat perilaku. Termasuk tadi yang disampaikan oleh UCHIYAMA Sensei terkait dengan ini kasus di Jepang ya. Jadi kan misalkan orang tua di Jepang itu banyak yang tinggal sendiri. Ya, tinggal sendiri gitu. Tinggal sendiri maksudnya nggak ada anak-anaknya di rumah. Jadi pemantauannya akan susah bagi pemerintah di sana untuk memantau orang tua itu gitu. Jadi kalau misalkan dengan sistem wireless ini, kita bisa mengamati perilakunya. Kebiasaan orang tua setiap hari seperti apa. Nah, kalau ada sesuatu yang berubah, maka nanti itu bisa dideteksi sebagai suatu kejanggalan, misalnya suatu kejanggalan pada sesuatu yang berubah. Nah, intinya tadi ketika ada sesuatu yang berubah, maka kita bisa lihat kejanggalannya. Nah, ini juga bisa dipakai di banyak hal seperti ke peternakan gitu, atau mengamati sesuatu yang bisa kita kontrol. Itu terkait dengan wireless sensing gitu, wireless sensing for smart home tadi ya, smart ya sih, bagian gitulah. Jadi enggak lagi kita pakai sensor-sensor yang terlalu banyak, bahkan bisa jadi aling-aling gitu. Wireless itu kan lebih ini, gelombangnya lebih ini dibandingkan dengan kita pasang beberapa sensor untuk anti maling gitu. Seperti tadi disampaikan, di satu ruangan ini kita bisa mendetek ada banyak gitu. Ada sekian orang itu bisa didetek gitu. Ada satu orang bisa didetek. Nah, ketika misalkan itu terkoneksi dengan sistem IoT ke dalam HP kita gitu. Jadi kita bisa mendetek, oh di rumah ini sekarang ada satu orang, ada dua orang dengan apa? Dengan low cost. Costnya lebih rendah, energinya lebih rendah dibandingkan kita beli alarm maling terus bunyi gitu kan. Oke lah ke HP kita entah alarmnya itu bunyi apa, tapi dengan ini kita bisa mendetek lebih baik gitu ya, lebih baik. Tapi perlu apa tadi? Perlu namanya machine learning. Dilanjutkan oleh Dr. KUDO tadi. Itu mengubah segala hal. Jadi misalkan kita pakai smartwatch kan kadang-kadang kalau pakai smartwatch, udah saatnya lari, terdetek kita jalan. Itu semua adalah dari data collection yang diolah menggunakan machine learning sehingga nanti didapat suatu kesimpulan. Kalau misalkan giroskopnya lagi begini, ada sensor apa di smartwatch kita begini begitu gitu. Jadi nanti itu kan terdetek suatu kejadian dan itu jadi teknologi yang dipakai dalam suatu smartwatch misalnya itu. Teknologi yang dipakai di situ. Jadi berpikirnya tidak hanya misalkan tadi ada beliau cerita terkait radio frekuensi gitu. RFID itu biasa digunakan untuk mengidentifikasi sekalian promosi ya. RFID itu biasa digunakan untuk mengidentifikasi logistik gitu. Jadi ada ID yang ditempel, dia aktif kalau terkena gelombang radio khusus dari readernya, ada pembacanya gitu. Radio khusus dari situ nanti terdetek di readernya mendetek, oh ini masuk, oh ini masuk, oh ini masuk, oh ini keluar. Tapi ternyata di situ berpikirnya kita lain. Oh ternyata di situ juga bisa terbaca data kekuatan sinyal dan arah. Phase tadi dia bilang, arah, angle-nya kekuatan sinyal lainnya. Berarti kita bisa mendeteksi sesuatu gitu. Nah itu yang kami gunakan sebelumnya yang tadi itu terkait millimeter wave, menggunakan gelombang milimeter untuk mengamati perilaku wallet itu bikin sarang itu gimana sih. Terus sekarang kan masih banyak perdebatan kapan sih waktu optimal kita panen sarang gitu. Menurut A gini, menurut B begini, menurut C begini. Nggak ada pengamatan pastinya gitu. Nah dari situ kita mencoba kapan sih itu waktu optimal gitu untuk memanen itu. Nah itu sebenarnya ada riset lanjutannya. Kita ingin melihat bagaimana pengaruh environment atau lingkungan di sekitar 10 kilo di sekitar walet itu terhadap produksi walet itu lainnya. Tapi salah satu problemnya adalah apa sih ini optimalnya dipanen gitu. Apa setelah ini kan semua masih pada perdebatan. Nah itu salah satu yang kita gunakan. Nah sekarang kita coba menggunakan RFID untuk memperluas jangkauan di satu sarang gitu. Nanti juga datanya kan sangat banyak gitu. Kalau tadi yang KUDO saya sampaikan datanya bisa 1.200 gitu. Jadi datanya bisa bisa ribuan atau puluhan ribu. Terus bagaimana kita mengolah data yang puluhan ribu itu? Disampaikan oleh KUDO saya tadi, kita bisa menggunakan AI dengan machine learning ini kan ininya terusnya ke AI dengan machine learning. Jadi kita bisa menggunakan data collection plus kalau UCHIYAMA saya bilang tadi deep learning. Jenis modelnya banyak gitu. Makanya dia sampaikan dia mencoba untuk mengamati sesuatu dengan cara yang lebih, misalkan tadi kayak terkait suhu di dalam ruangan kan dingin segala macam, kita nggak tahu benar-benar suhu pastinya itu berapa gitu. Kalau kita menggunakan sensor-sensor lain mungkin agak susah. Jadi dia menggunakan berbagai data, physiological data dan environment segala macam, sensor-sensor ini dikombin dari situ sehingga nanti didapat di smartwatch kita real suhu tubuh kita berapa gitu, bukan hanya suhu dari lingkungan yang terbaca di smartwatch misalkan seperti itu. Jadi banyak. Kenapa saya juga undang matematika? Karena yang terkait data, gitu. Terkait komputasi. Gitu. Jadi itu juga bisa menjadi salah satu bagaimana machine learning dan juga pengolahan data itu juga dipelajari di matematika. Jadi biologi apalagi kan mungkin kalian terbiasa kalau misalkan yang ke lapangan mengamatinya menggunakan sesuatu gitu. Nah ini ada beberapa model yang mungkin bisa digunakan yang ya kita gunakan sehari-hari sebenarnya gitu, nggak perlu tools yang benar-benar khusus gitu, tapi bisa untuk mengamati suatu perilaku. Nah itulah tadi yang disampaikan oleh UCHIYAMA Sensei dan KUDO Sensei. Oke, selanjutnya ada yang mau ini ditanyakan? Adalah nanti dulu pada konteks. Secara konteks kita bicara di belakang aja. Kalau ini bebas nih. Kalau Pak Yunus ini panjang ceritanya ya, di belakang aja lah kita ngobrol. Ya, Mas Sisa. Silakan di luar konteks kehidupan di Osaka gimana boleh. Bahasa Indonesia nanti ditranslatekan. Ada? Ya, silakan. Boyan. There are one question from my students. Not student. Alumni.
Thank you very much for the opportunity. Let me introduce myself. My name is Kevin Brian, and I'm a graduate from the Physics study program. I would like to ask to Hiroki Sensei. I've just started studying about AI. If we intend to develop an AI system capable of prediction and classification image, for example, detection panda image, such a system would require a large data set of such panda image. Furthermore, if the AI system we aim to develop is intended to predict or generate code structure, similar to the role of the ChatGPT, what form of dataset would be required in this case? The second question, regarding prediction to generate or generating Python code structure, would it be sufficient to create a deep learning model? Thank you.
Do you get the question? The question is about, yeah, I'm not sure I can, the processing of AI is true, so how I can use AI to make sure about the model is, this is the right model, this is the good model, and also about the code or something by the AI. So maybe that is the main question. The main question. This is about how to use, how we believe what we're doing is right, and then the main is how to use AI into the good. How to we believe the result is correct. When using parameter. Yeah. Yeah, this is the question. Maybe he already tried something about the medicine, so maybe you can tell your experience while using AI for processing the data or making a model.
It's a good question and difficult to answer. Do you have any idea? Thank you. explainability.
So maybe you can talk about your experience here process. Medical
Actually, we are working on the medical AI, and we try to building the model with explainability. Yeah, this is because in the medical field, the output of the model can be explained by the specialist, like it's maybe doctor or the IT specialist or someone. So.
How to in my imagination, you get a lot of data, and then we start working with as you mentioned, there are a lot of different data, so we combine it by machine learning, and then we can try AI to get the model on. How the process, maybe how the process you using AI to get the output. Basic process. Just the basic process.
Deep learning.
Using deep learning. I mean basic process from you're collecting the data and then until output.
It's exactly what we are doing in the Salah Wallet. We record the video to observe the ground truth, actual bird behavior, and that can be used. That's video recording can be used for the training of the model. So the basic process is like that. So as I said in my sensing part, the data collection is super difficult, hard. It's time consuming. So there are many research to reduce such effort for the data collection. So sometimes it's called zero-shot run. So we just collect data without any data. But we can force the AI model to distinguish the difference between the data.
And how
to find some groups in the data.
How to make the AI model.
How to make AI model?
How to make a model with AI?
Architecture. I mean,
yes.
There are multiple types of
Yeah.
AI models. Some are good for the sequence of the data. So it's like for time sequence. Some are good for the images. So depending on the structure of your data, you need to design the architecture of the AI.
Oh yeah, I got it.
That is important. Variation of the model.
Oke, Kevin. Jadi begini apa namanya, dalam membangun suatu model AI bukan kita kayak menyerahkan ke AI yang ada gitu. Bukan begitu. Jadi tetap menggunakan data collection. Machine learning sendiri terus menggunakan deep learning gitu. Menggunakan deep learning itu adalah suatu konstruksi AI. Konstruksi AI yang mereka gunakan gitu. Nah, modelnya itu akan berbeda-beda tergantung dengan tujuannya. Bisa ada yang muka, data, apa segala macam, itu tergantung itu. Nah, pada poinnya adalah proses ini bukan kayak kita ngasih data, GPT mungkin gitu. Tapi proses ini lebih ke kita collection data. Terus data itu nanti di training menggunakan suatu model tertentu. Nah, training menggunakan suatu model itulah kita umumnya menggunakan AI, atau hasil training itu menjadi AI tersendiri gitu. Hasil trainingnya itu, outputnya itu nanti menjadi AI tersendiri yang akhirnya kalau kita kesini sakit bahasanya gitu. Kalau kita mundur ke belakang kok sehat gitu, itu bahasanya. Jadi mereka mendevelop AI itu sendiri gitu. Nah, AI itu nanti akan diaplikasikan ke dalam suatu tools tertentu, misalkan ke handphone kita. Misalnya handphone kita bergeser ke kiri misal. Oh, dia tahu bahwa handphone ini sedang bergeser ke kiri gitu. Nah, mungkin itu yang disampaikan oleh beliau ini. Oh, yang meluruskan.
Jadi, nah itu tadi Pak, yang kan kita membangun sebuah model deep learning. Nah, itu kan berarti kita harus ada data training dan data setnya. Nah, data setnya itu kalau tadi kan disampaikan kalau misalkan kita pakai data, kita ingin memprediksi atau mengkualifikasi suatu gambar, misalkan gambar muka gitu. Tapi kan kita perlu data-data seperti gambar hidung, mata gitu kan. Nah, yang mau saya tanyakan tuh gimana kalau misalkan yang kita minta itu sebuah coding gitu Pak. Nah, kan di ChatGPT kita bisa diminta tolong buatkan sebuah coding untuk membaca untuk menghitung ini misalkan. Nah, itu datasetnya gimana Pak? Dia bisa memprediksi coding yang kita minta itu Pak. Nah, misalkan di ChatGPT itu kan kita bisa minta tolong buatkan sebuah coding untuk menghitung gitu Pak, dalam bentuk coding Python misalkan. Nah, kan mereka dapat jawabannya kayak NumPy. Nah, kok AI itu bisa dia mengeluarkan jawaban itu dalam bentuk coding?
Jadi kan dia itu mengkonstruksi.
Iya, kalau gambar saya ngerti Pak, kalau yang itu yang berupa teks gitu.
Kenapa bisa mengeluarkan itu? Atau
Ya, bisa menjawab itu Pak, permintaan kita itu. Kita minta tolong buatkan coding. Nah, keluar coding dari mereka itu.
sebenarnya itu tadi jawabannya adalah trainingnya banyak, data trainingnya banyak.
Jadi kalau misalnya cerita kemarin, intinya data trainingnya banyak. Semakin banyak data trainingnya itu semakin akurat. Kenapa kita bisa bertanya secara akurat? Karena GPT itu juga di training pakai banyak sekali data. Banyak data ini macam-macam ya, bisa paper, artikel, apa segala macam, itu di training dengan banyak sekali data gitu. Jadi kenapa itu bisa keluar ya, karena memang dia sudah di training dengan banyak data, akhirnya menghasilkan output tadi sama seperti yang disampaikan oleh UCHIYAMA Sensei. Jadi kalau misalkan terjadi dia di training data ini di training terjadi perubahan perilaku, maka itu akan terdeteksi sebagai perubahan perilaku gitu. Nah, sama juga kalau misalkan di GPT ya, itu intinya data trainingnya itu banyak sekali gitu. Makanya kemarin sempat ada konflik juga di situ. Bagaimana sama juga ketika kalian menggunakan AI, kalian training AI itu gitu. Jadi saya ngajarin pakai AI gitu. Di training dulu, jangan langsung minta, tapi di training dulu dia gitu. Misalkan kalian mau ngerjain sesuatu gitu. Jadi sebelum kalian ini kalian training dulu dia. Namanya training itu latih, kalian latih, terus kasih data macam-macam gitu, kasih data ini, oh data ini, data ini, data ini, supaya pengetahuan ini nyampe. Nah itu nanti di set, makanya disampaikan tadi ada memorinya, dia itu di set ke memorinya dia, pikiran dia. Selebihnya adalah approximasi, pendekatan, apa namanya? Ya pendekatan lah. Selebihnya adalah pendekatan berdasarkan segala sesuatu training yang ini kita. Bahkan kita bisa bikin AI untuk Universitas Palangkaraya aja. Datanya apa? Data seluruh Palangkaraya aja. Misalkan di mana letak bla 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 gitu. Jadi dia akan spesifik menjelaskan lokasinya ada di jalan ini bla 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 segala macam. Ruangan ini akan ada di sini bla 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 segala macam. Fasilitas yang ada sekian-sekian. Itu tergantung data training yang kita masukkan ke dalam sistem AI itu sendiri gitu. Kenapa dia bisa ya? Karena dia sudah di training gitu. Pada poinnya sih.
Nanti lanjut lagi biar
ini sudah mau jam 6 ya. Sudah maghrib lewat gitu. Lewat. Nah mungkin maybe there are closing statement for both of you to motivate our student.
How they can get a scholarship, I think. Maybe master
Work hard.
Study hard. Yeah, maybe please, if there are any closing statement, especially the opportunities in the future. About the research.
The research.
Yes.
So yeah, I want to ask one question. So how many of you have used ChatGPT?
Siapa yang pakai ChatGPT? Tangan.
almost every day.
Yeah, me too. So, but yeah, please don't forget that ChatGPT is your good partner, but you need to make sense of the output of the ChatGPT. So yeah, of course, you can ask ChatGPT to write any code program that works, but yeah, if you use that output, you have to you have responsibility of the output.
Okay.
So, but yeah, ChatGPT is very powerful, and we can do a lot of things, much more things what we could do before. So, I think the technology is going much faster. So, let's make smart society, bright future together.
Oke, yang disampaikan beliau, ketika kita pakai GPT, kita harus bertanggung jawab. Ya misalkan ada outputnya nih, jadi dari output itu kita juga harus bertanggung jawab terhadap apa yang kita gunakan. Itu yang pertama. Nah kita lihat ChatGPT ini sangat powerful ya, banyak yang bisa dilakukan. Nah itu artinya menandakan bahwa teknologi ini akan bergerak sangat cepat gitu. Teknologi ini akan bergerak sangat cepat, jadi pada intinya kita harus lebih pintar ya. Kita harus lebih pintar menggunakan AI. Nah itulah pesan dari KUDO Sensei ini.
Yeah, thank you for listening. Oh my God. I got happy. Future corporation.
Yeah, one of my students is working for medical image. Maybe
we can start the progress.
Yeah, I'm working on medical AI, so yeah, if you have interest, let's collaboration with them. Or, yeah.
Jadi kalau Kudo Sensei dia apa namanya banyak bekerja di bidang medical AI untuk medis gitu. Nah, tapi outputnya tetap dibaca oleh spesialis atau spesialis AI gitu. Jadi kalau misalkan emang kalian ada berminat ya silakan nanti hubungi beliau gitu. Jadi sekarang pun medis juga ya mungkin dokter spesialis juga pakai GPT gitu. Ya, semuanya gitu. Tapi dia akan lebih spesifik untuk membangun suatu AI tertentu yang memang itu khusus untuk medis, Sekarang kan mungkin masih general. Nah, jika memang ada yang berminat ke sana nanti silakan bisa berkolaborasi bersama Kudo Sensei. Sudah cukup ya, kita sudah mau jam 6. Thank you very much for your presentation, UCHIYAMA Sensei, Kudo Sensei, arigatou gozaimasu. Terima kasih banyak juga yang sudah hadir. Semoga ada hal-hal yang bisa didapatkan di sini dan juga paling tidak memotivasi kita. Dari Walmon juga terima kasih banyak. Nanti mungkin kita akan lihat apa yang bisa kita sensingkan di Walmon. Apa yang kita sensingkan di Walmon. Dari data-data yang ada itu mungkin bisa kita buat suatu pengamatan tentang perilaku entah apapun itu. Oke, terima kasih banyak. Selamat malam. Saya kembalikan ke pembawa acara.
Thank you, sir. Okay, ladies and gentlemen, after the insightful presentation and discussion, we will now present certificates of appreciation. The certificates will be handed over by Bapak Made Dirgantara MS.
Certificate. This is proudly present to Dr.Akira UCHIYAMA as a guest lecturer in Palangkaraya Visit of International Workshop on Smart Sensing and Artificial Intelligence for Future Society held by Physics Study Program Faculty of Mathematics and Material Science Universitas Palangkaraya. Palangkaraya, September 2020. Arigatou gozaimasu. The other one is maybe from for Dr.Hiroki KUDO. Not that itu kan nama? Itu KUDO. Oke. Oke, sudah cukup.
Okay, ladies and gentlemen, let us take a moment of prayer to close today's program. You may now pray according to your own belief. Berdoa dipersilakan.
Terima kasih.
Berdoa telah selesai. Distinguished guests, ladies and gentlemen, this concludes the Palangka Basic Talk 13. On behalf of the organizing committee, we sincerely thank our guest speakers, our moderators, and the dean, respected lecturers, and all students who joined today's program. May today's workshop bring new knowledge, inspiration, and opportunities for collaboration in the future. Semoga kegiatan hari ini memberi manfaat dan semangat baru bagi kita semua. I, as the MC, apologize for any shortcomings in guiding this program. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore dan see you at the next Palangka Physics Talk.